Hey guys, we're back with the notes for 11.3. We're going to be talking about writing exponential equations again. So today we are talking about looking at a word problem, figuring out what the initial value is or what it's starting with, and what its change is. It's usually going to be a percentage. So we're looking for if it's more than 100% or more than one whole, that's going to be growth. If it's less than 100% or less than one whole, that means that it's going to be decay. That'll help us make our decisions about whether we use a big number or a small number, okay? There's only 4 problems on this, so let's go ahead and get started. Problem 1. It says a toy is made up of cylindrical rings stacked on a base, as shown in the diagram. The diameter of ring 1 is 87% of the diameter of the base. So 87% is small. It's less than a whole. So that means that we're getting smaller. I'm just going to make a note that we are doing decay. For ring 2 through ring 7, the diameter of each ring is 87% of the diameter of the ring directly below it. The diameter of the base is 5 inches. Which function can be used to find the diameter in inches of ring R? So here's my question. What's the original? What's the starting value? What's the base? 5. Okay, so that means that we can cross off any of the answers that don't have an initial value of 5. All right, so our second setup is asking, well, 87%. Let's think about it this way. We have 100%. That's one whole. So 87%, how would we change that to a number less than 1? Well, we would move our decimal twice, and we would make it 0.87. So we are not subtracting that from R. We're making it exponential. So we're multiplying 0.87 over and over and over and over. 0.87 is my change. That's my multiplicative rate. Therefore, my answer is F. Okay? Take a second, write down anything you need. We're going to go to problem 2. All right, problem 2. It says, in recent years, Austin, Texas has been the fastest growing city in the country. The function here can be used to predict the city's future populations in thousands over the next several years. Which statement is true about Austin's growth population? Okay, so I want to make sure we know we're looking for something true. So, y equals a times b to the x power. Again, we're usually starting with a number and we're changing it by a percent. So bigger than 1 is growth, smaller than 1 is decay. Our problem right away says that it's growing. Okay, so we're going to want a number bigger than 1. I look at it, I notice it says in thousands. So I rewrote this problem to say 885,000 is my starting number. And I kind of separated that decimal out so that you know it's bigger than 1. It's one whole plus that decimal amount, okay? So we are growing. I have a number bigger than 1. Let's see which one makes sense. The function indicates the current population is 1,029,000. That number is not even population. That number is talking about the percentage that you're growing. That's where the 1029 comes from. Okay, so this isn't even talking about population. Okay. Option B, it says the population after X number of years will be 1,029,000. Again, we're not talking about people with that number. That's your change. You're saying it's increasing by this amount. So we're not talking about people on these units. Okay. Option C says the population is growing at a rate of 2.9%. Well, we talked about moving the decimal, right? Let me zoom in real quick. If I were to zoom in real quick and move my decimal, boom, boom, wouldn't that be the same as saying 2.9%? Yeah. Okay, and we know it's growing, it's increasing. So then the only other one we got to check is it says the population is increasing by 885,000 people per year. No, that's where it started at. We're not increasing that much. That's our starting value. Therefore, the only one that makes sense is C. Okay? Take a second, write down anything you missed. We're going to go to problem 3. Perfect. For problems 3 and 4, there we go. For problems 3 and 4, we are straight up writing an equation. Remember that means we are in the format of A, parenthesis, b to the x. A is what we start at. B is our number. If we are adding, sorry, let me write that in a different color. So we are going to do 1 plus something if we are growing, because we're bigger than 1. We're going to do 1 minus something if we are decay. All right, so let's look at this first one. It says there are 500 mosquitoes in the park in 2010. The amount triples every year. Well, triples is easy. Triples just means 3, right? Write an exponential equation to represent the population change. Well, what's my starting? What's my initial value? 500, yep. What am I multiplying by every time? Triple means times 3. And I raise it to the x. Done. That's all we're doing. Okay. Let's try the next one. Oscar bought a new truck for $15,000. The value depreciated 10% each year. Okay, now 10% is a little tricky. Let's focus on this idea now. So if I know the original value is 15,000, that's a comma, sorry, 15,000, I don't want to put 10 in here because 10 is bigger than 1. 10 would be saying that we're growing. We're multiplying by 10 every time. This says depreciated. Depreciated sounds a lot like decay to me. Decrease, right? It went down in value. So if I think about it this way, I know 100% is 1. So if I were to take off 10%, that leaves me with 90%. Now, I don't want to say 90 because that's bigger than 1. So we're going to think about that like a whole number. 90% is the same as saying 0.90. So that's what we're going to put in our blank. We're going to take 0.90 and we're going to write that as our b. It's smaller than 1. It's dropping a 10% dip. Same thing. If I say you missed 10% on a test, that means you got a 90. If I were to divide your numbers, I say you got 90 out of 100 right, it's 0.9. You guys just know how to change it to decimals. Okay? All right, well, that is the last problem for the notes. So if you've got it covered, go ahead and get started on your assignment. You're starting on page 174.